Hello and welcome everybody to this training today. We are here from Fronius and we would like to present you in this webinar our backup power solutions. Basically, it's an update all about the new solutions from Fronius. My name is Hans Pelzer. I will guide you through this presentation, which will take about 30 minutes. And beside me is also Anthony Moises. He will take care about your questions. Feel free to send your questions during the presentations and we will answer them immediately and also after this presentation. Now, what's on the agenda today? I first like to start with the Fronius Backup Power Solutions. In general, what solutions do we offer from Fronius? Then all the required components, what you need in detail for the specific solutions. And I also like to show you the installation and commissioning. Finally, we end up with some news from Fronius about backup power solutions, which we will present very soon. If I start now with the first slide here, I'd like to give you a short overview about our backup variants. Basically, two solutions can be offered with the Gen 24 inverters. There's on the one hand side, the PV point, basic power, backup power, which is supplied single phase, maximum 3 kilowatt with a specific socket. This can be used on all Gen 24 inverters. If it's a Primo, Simo, whatever power class, it even don't need to be a plus inverter. Or the other solution with the full backup solution. Here we need to have a Gen 24 plus inverter. It can be a Primo or a Simo. If it's a Simo, we need power class from 6 to 10 or 12 kilowatt in the new inverters. We have a maximum 12 kilowatt three-phase output, AC output, which we can with that supply all the backup power loads. Therefore, you also need a battery. Battery is always also required, and a smart meter from your smart meter, of course, and the switchover component. I will show you in the next slide what you need exactly for that. The working principle of the PV point is that we have a specific output socket on the Gen 24 inverter, and there you have your socket, your 230 volt socket. With that, you supply your loads in the household. So your specific loads which you need, especially in the grid outage moment. As you can see here, we don't need a battery. It's just a socket, a cable which is connected on the inverter. And here we connect our socket, and on the socket we can plug in all the loads we need. In the full backup, you see that we have a backup power switch required. So two additional components, basically the battery, of course, and the backup power switch. The backup power switch can be different components. I will show you later which components you need. Take care that you have a Simo only the 6 to 12 kilowatt units. Primo, on all Primo, it would also work, Primo plus inverters, and also the Simo 6 to 12 kilowatt would work with it. Before I now continue, I would like to have a short question to you. Which backup power solution do you prefer, basically? Is it the PV point? Is it a manual switch solution? Or is it the automatic switch solution for three-phase or in a Primo, also single-phase automatic switchover? So please click on the answer you prefer and you mainly use. And I would like to wait another few seconds to get, now we have more than 80% selected. Good, thank you very much. I can close that now, and the result is that 89% saying that the automatic switchover is the preferred solution, and 11% the PV point. There's no one with the manual switch solution, but I would also like to show you that later on, because that's maybe also a good alternative. So thank you for your feedback. I'll now continue in my presentation, and now some notes about backup power. What do you need to know? Basically, full backup requires additional components. I already told you that: switchover components, conductor, the relay. Second, we have a higher frequency in full backup power mode with 53 Hertz. We supply all the loads, but all additional solar inverters will be kicked out. So we have only one inverter running in backup power mode. That's important. Second, there is a short switch over time, about up to 30 seconds. We will reduce that. I'll come back with more information, detailed information about that at the end of the presentation. And so there is some time, of course. And third, we have a maximum operation time in backup power mode of 2,000 hours per year. So on average, about 20% of total operation. So this is in the terms of warranty. So please take care that you actually don't use the inverter in off-grid system, because then if we would see after 3 years that this inverter has run 100% in full backup power mode, we would probably not give you the full warranty. Additionally, specific requirements in some countries, you will have on the Primo range, single phase, a 1 or 2 pin switchover, in a 3 phases, 3 or 4 pin switchover. So depending on the country, in some countries you need just to switch the phases. In other countries you also need to switch to neutral. So there are these two different options. Do you need to switch to neutral or not, basically? We have all the diagrams in the operation manual, which is also included document in this webinar. So feel free to see these diagrams at the end of the operation manual. There are all these diagrams for different countries with neutral or without neutral switchover. Then we need to separate the backup loads. That's also sometimes required because of the high power, needed power. If you have more than, let's say, 10 kilowatt required, it can be, of course, difficult to start up the inverter. Therefore, it's very often good to split up the loads in specific backup power loads and standard loads, which are not so important. They also can be switched off when there's a grid outage. Then we have two solutions: manuals, a switch or automatic switch over in the full backup solution. And sometimes other requirements like grid protection devices are sometimes needed as well. In some countries, the grid operators would like to have that, and therefore please clarify that with your local grid operator what's exactly additionally required. For the specifications, we have permanent power on the PV point of 3 kVA and a maximum power single phase of 4 kVA for about 5 seconds, just to start up a little bit higher power. In the full backup mode, we have, depending on the power class, this is only the Simon now, 6 to 10 kVA. Of course, if it's a Primo, it's the same. So whatever the power class of the inverter is the power which can be delivered in backup power mode as well. Additionally, we can supply a bit more, also this 12 kVA or 4 kVA per phase for 5 seconds, and 3.6 kVA permanent per phase. So that's also the different phases can use different power, of course, and it's 3.68 is the maximum per phase in the 3-phase system. The battery discharging current is maximum 22 amps. So with it, that's also important sometimes for night consumption. So because in night you need all the energy from the battery. So therefore we get 22 amps from the battery. If it's a 400-volt battery, so the bigger battery of BYD, for example, you will achieve about 9 kilowatt or kVA power from the battery. So that's also a kind of limitation. If you have using a small battery with only 200 volts, we are limited by 4.5 kVA. So therefore, make sure that you have in some locations where you need more power, that you have also the high battery voltage. So now to more details about the PV point. So in the PV point, we have also two solutions. The PV point standard integrated in all inverters with just a socket. This PV point is only active in backup power mode. You need just the 230 volt sockets and the RCD type A 30 milliamps. And then we have also now the PV point Comfort. This is an additional retrofit PC board, which will be mounted in the inverter on the AC, where you have the AC connection. And this delivers then permanent supply of 230 volts, 3 kilowatt. So therefore, you just you can decide which are the most important loads, and they can be connected on these sockets here, and you have then permanent supply. Only the grid outage moment you will have about 15 seconds, 20 seconds without supply, but then it will start again automatically with the PV point Comfort. So take care that you have also here RCD type A, and probably also fusing is required. 13 amp or 16 amp fuse is required. So if the fuse in the AC line is higher than 16 amps, you should also have here RCD including fusing of 13 amps. Here's also the wiring diagram. What you need to take care, you have this 3-pin socket on the inverter where you get out this voltage of the PV point. You just need to connect here a cable, 3-pole cable, and you need to connect first the left hand neutral to the grounding block. There you need to do this PN connection that also the RCD will work. So that's it actually. Then you just need to activate the PV point in the web UI, which I will show you later. When you use the PV point Comfort, as I said, this is this retrofit kit. The retrofit kit is a PC board which will be mounted just below the AC connection. It's very simple, 5 minutes work. You just split up the single first phase, get it through this PC board, and use then the relays on this PC board to switch over once from the grid, and if the grid's out, from the PV point socket. So also we got an easy solution. Advantage is here that you have an automatic switch over from this PV point socket, that there's no unplugging necessary. So usually you need then to connect these loads on this socket. In this case, you can leave them connected at this supplied socket, and you always have supply. And it can be retrofitted in all Gen 24 inverters. So if it's a Primal, Simul, all Gen 24 inverters can use this PC board. Good. So that's about the PV point Comfort. Now, if we come to the manual backup power switch, so the full backup solution, but now with the manual switch, we have also here two solutions for single-phase systems or three-phase systems. You need this, this switch, a 1 or 2 pole switch over 20 to 63 amps, depending on the power you need, and or the 3 or 4 pole switch over with 25 to 63 amps with this auxiliary contact. Additionally, what you need on both actually to get the feedback to the inverter that the switch is off, in off position. always you need a switch with 3 positions: position grid, position 0 off, and then a position off grid power or full backup. So that's a rather simple solution, not expensive, so real good basically idea for all the customers who would like to save money. The wiring is also quite simple. You see Q1 is this manual switch where we switch off the 3 phases in this case, and also maybe the neutral. So this is the 3-pole switch over where we switch off only 3 phases. We need a feedback to input 6 and input 7, 12-volt signal from this switch when we are in position 2 or in backup power mode position. And on the other hand, we need also to switch off the inverter in position 0. That means we have 2 closing contacts. So one from position 1 and one from position 2, which are connecting in wires from the wired shutdown pin. So wherever you are, position 1 and 2, is closed and the inverter can run. If this is open in position 0, the inverter will immediately stop and interrupt the production. So therefore, make sure, don't forget this, because otherwise you could have 2 voltages together from the grid and as well from the inverter. Yeah, now to the installation of the automatic backup power switch over. Here we have also basically 2 solutions. The components which we built in the switchboard. So you do the wiring of the conductor of the relay on your own. Therefore, you need, of course, to check the wiring diagrams to have the right ones. You need as well additional space in your switchboard. That's sometimes a little bit tricky, but it is a cost-effective solution, and usually you don't need too much space as well in your switchboard. For a new house, of course, this would be the preferred solution, probably. The other one is the external solution. Here we have, for example, an NVTech box, a supplier from Europe, from Germany, who is doing these boxes for us, and he's preparing all the required components, like the conductor, like the fusing for the inverter, smart meter is also included, and the relay. This has got a higher price, but it's of course the easier wiring. You don't need to do a lot of wiring. You just get out your 3-phase from your switchboard and get into the inverter again, and to the switchboard again, and you need 1 communication cable to the inverter. There are different solutions available, so please check your country. You can also find there on their webpage a configurator tool where you can decide which box you need in your country. Yeah, these are the required components. Basically, 6 amp fusing, 12-volt DC relay, a small relay with 2 auxiliary contacts, one normally open, one normally closed contact, the Fronius smart meter, and 1 or 2 contactors. So in some countries, you need also 2 contactors in serial for higher safety. Usually in Austria, for example, we need only one conductor with 35 to 63 amps and 1 auxiliary contact, a normally closed contact, to give feedback to the inverter if the conductor is off or on. How does it work? You see, K1 is here a conductor which is in this position, grid operation on. So it's all grid supplied. The inverter can run in grid mode. Also, all the conductors will be open, and so the feedback signal are open. K1 and K3 auxiliary contacts are open. K1 is supplied from the single first phase 1, via a fuse, 6 amp fuse, and K3 normally closed contact. So as soon as the voltage, there's a grid outage, the conductor will open the 3 phases in this case, and then the inverter will get feedback from K1 normally closed contact on input 6, then give the K3 the signal to start, so that our small relay will then be supplied, close also contact input 7, and interrupt the line from K1 from the coil. So because otherwise, if grid would come back very soon for a short moment again, the conductor would close again, and that's not good, of course. So we need to avoid this. Therefore, we have the K3 open contact here to interrupt this line here. So in this case, when we have all the feedbacks, we will then start with full backup operation, and the inverter would start again with the 53 Hertz to supply the backup power loads. Now to the commissioning. We have on the interface, on our communication interface of the inverter, 3 connectors, 3 sockets. The first one is the wired shutdown socket, input plus minus, which you need these 2 cables for these manual backup power switch in position 0, must be disconnected in position 0. The second one is the Modbus connection, where you connect your smart meter and your battery. I think you know that already. And on the right hand side, this 16-pole plug, you connect, you get your feedbacks and your IO 0 for the K3 relay, and input 6 and 7 feedback from the conductors. That's it actually. So you need basically one communication cable, 8-pole cable, cat 5 or higher, from the inverter to the switchboard, and here you get your feedback. You connect your feedbacks from the conductors as well, K3, the small relay. For the settings on the web UI, you just need, when you do the commissioning the first time, you will come to this point, functions and IOs, and here you just need to get to the point backup power, activate backup power, and then backup power mode PV point or full backup. Full backup means full for the whole household with this automatic switchover or manual switch, and PV point comfort or PV point standard. So you can select this here, you save the settings, and that's it basically. So not more to do. Yeah, make sure that you have also your battery connected if you go to full backup power selection. Otherwise, you cannot select full backup. You can only select PV point without battery. Good, that's it actually. Further informations. Now, some news from Fronius. We get a new software end of June, beginning of July, firmware 1.32, which with this software, we have reduced the switchover delay time to about 15 seconds. And also the manual setting of backup power frequency is possible now. So we can reduce the 53 Hertz to, for example, 51 Hertz. If you have any load which is not working correctly with the 53 Hertz, then you just you are able with this software to manually set another frequency between 50 and 53 Hertz. So that's basically can be adjusted. Second, we have new hardware solutions for the manual switch and a complete automatic switchover component from Fronius, which we would like to show you on the Intersolar in actually next week. feel free to contact us on June 19 to 21st in Hall 4, booth 310. We are here to give you more details about that. Also, we will have a webinar finally 2 weeks after Intersolar, which you can watch, where we will present all the highlights from the Intersolar and also, of course, the new backup power solutions from Fronius. Further information, the recording will be forwarded in next days as usual. You can also find enclosed operation manual of the Gen 24, where you can find at the end the diagrams for different countries, different switchover components, 3-pole, 4-pole, manual, automatic, PV point, and so on. So feel free to use these diagrams. And of course, we'll also have different other webinars for these topics and trainings. Feel free to register here. Good. Then I would say I'll have a look to your questions, and I would just open the questions now. So until now, we haven't received any questions. I would say I will switch off my microphone now and webcam. I will stay online with you. Feel free to use the time, send your questions, and we will answer them immediately. Thank you very much and have a good day. Enjoy your time. Bye-bye then. See you.